Okay, so this is a car seat we're going to flatten, so I'll just create the pieces that the car seat's made from. So I'll go through the scan, select these surfaces here. I'm just taking the patches that came in from the laser scanner and simply selecting them to make the surfaces that I want flattened. Just get the bolsters on both sides. And then finally these pieces here. Once we've selected all the pieces, we'll just hit this green checkbox here. And the next step is to go into convert this into an exact flat part. So I'll just hit the convert to exact flat. So it's going to take SOLIDWORKS render mesh, bring it into exact flat. So there's a lot happening here. What it's going to do is take all those meshes that were created by the laser scanner and retessellate them, and basically that allows us to now apply a material property to the mesh and flatten it and get a very accurate flat. So once it goes through, as I said, this is basically updating the meshes, creating or pattern mesh information, and the next step would be to actually select a material. And you'll see once it goes through this process, we'll be looking at the material editor, which allows us to select what material we want on the car seat. So here's our material editor. It's converted. We're going to convert this now to a flat piece. I'm going to take leather as the material I want used, and I'll just hit OK here. What it's going to do is now apply a leather material to that car seat. You can see it's changed the color. I'll go into the flattener here, and once we're in the flattener, we have over on the left hand side is our 3D model, and this blank space here is going to be our 2D flat pattern pieces. So the first thing I want to do is adaptively remesh this model, and what that's going to do is retessellate it or make a better mesh for flattening. And as you can see as it's going through here, now we have all our flat patterns. Now these aren't optimized patterns, these are projected flat patterns. Exact flat's a two-stage flattener, so the first stage is projected flat. Next stage is, I'm going to just use one of our pre-flatteners, and I'm going to now hit our optimize button. Once I do that, you can see here it's going to go through the pieces and create flat pattern pieces from the pieces I've selected here. I'm running a Lenovo laptop, and it depends on how many cores are on your laptop, or on your computer. But if you have a desktop that you're going to be using, this process will be much faster. Um, so as it completes one set of patterns, it works on the next set. As I said, if I had 12 cores open, it would do, this is 12 pieces, so each piece would be running instantaneously. Since I'm on a laptop that has 6 cores, um, it's going to take a little bit longer time. But it's still a lot faster than doing it by hand. So we can take a look at the pattern pieces that it's working on. We pretty much got most of the pattern done. It's just working on a couple other pieces here. Most everything's done. It's just working on this last piece here. Um, so what the software is trying to do is basically find the best um, pattern it can create with zero energy across the surface. Now, this is the um, seat part that we're looking at here, and it's pretty much flat. So I would assume it's going to take a couple more minutes just to see if there's a better solution to the flattener. But I believe it's going to just stick with what it's doing right here. So if you look at this, there's curvature going down, and this is the seat part of the seat. So it looks like we're almost ready. Okay, so it's optimized here. I'll just hit OK. And once it takes these pieces, it's going to put them onto what we call our pattern view. So we'll be looking at the 2D pieces, and this is where we would add seams, notches, and these type of things. So it's going through each one of the 12 pieces. It's going to lay it out onto our surface for adding seams. Okay, so now it's just rebuilding the pattern pieces. As I said, we're going to be adding our notches, and going through, after we add our notches, we'll go through and export the pattern pieces out to the cutter. So once we have that done, you go into our pattern view. Here's our pattern pieces. I can move them around if I wish. Basically just adding um, this kind of line things up, and I can show some of the tools for finding pieces. We have a find tool. We can just click on an edge. Once we click on an edge, it'll find the corresponding piece to that edge. So I'll just click on the edge, and it picks up the piece that goes to it. Click on this edge, it picks up the other piece. If I go in and I zoom in here, I'll just show you. So we have these two surfaces. What I'll do is go in and I'm going to simply add seams. I can just click an edge here. Once I click this edge, and let's say this edge here, on the opposite side you can see it's add the seam. I can go in and select the seam type, and we'll use a 10 millimeter seam, and we'll just go with a notch chain, half centimeter V, and you can see as I clicked on the V notch, it automatically puts them exactly where the pieces have to be sewn together. So that's how easy it is to add notches. And the final part of the process would be um, going in and sending the pattern piece to the cutter, and we can do that simply by going into our marker view. Once we're in our marker view, that'll open up our cutting table software. So here's our marker. We have all our pieces. I've done 10, and it's created a marker set to go to our cutter. I just basically export that, and I'll select the cutter I'm using. In this case, it's an Eastman cutter, and I'll just export the file to auto-generated DXF, and we'll save that on our desktop. And then basically if I look at the marker that I've created, it says that it's created, it's ready for my cutter. I'll just open this up and show the cut file. Uh, Here's our auto-generated marker here. So we'll just open that up, and then we'll be able to take a look at what the cutter would be reading. This will have the information such as your notch information, also have grain lines, and it'll have piece IDs. So this is the cut file for the cutter. You can see here it's got the grain direction, it has the piece number and piece IDs. It also has the information, as I said, such as notches and seams. So all that information is now stored in a file that's ready to go to the cutter. The total time it took to do this whole process was 11 minutes and 29 seconds. If you have any questions, feel free to send me an email or give me a call.